no matter what you do on these. Oops, I'll close that out. I'll make that go away later somehow. How'd I do that? Silly. Okay, so first and last step is always going to be that substitution business. Next one over, totally the same thing. If I put 2 into this, no problem. It's the square root of 3 times 2 minus 2, which is 6 minus 2 is 4. The square root of 4 is 2. Same as if I graphed that. You know what it looks like. Square root graph. Go to x equals 2. What's the height? 2. You move on. So limits are great. They're seemingly simple. Just plug it in. Unless it's undefined at that value. And algebraically, that means when you try and sub it in there, you end up dividing by 0. And that's where it doesn't work to directly substitute. I cannot substitute yet. And the yet is important because if we could algebraically make it so I could substitute, like get it to cancel that cosine squared or something like that, then we'd make this happen. I'm not going to evaluate that one. I just want you to notice that I can't put 0 into that expression. The next one over, you just try it. Every time you see one, say, well, let me try and put, now n is a different variable. I can use any variable I want, but the limit as n goes to 16. That means you can put 16 in for wherever there's an n. If it's not illegal and you don't divide by 0, then why not 16, not 14? So log base 2. All the stuff we've learned will possibly show up algebraically in a limit. Square root of 16 is 4. The 2 to what power is 16? Remember, that's the question you ask when you do a log. It's always 2 to what power gives you what's inside the log, and that's 2 to the 4th. And that means the value of that is 4. So 4 over 4 is 1. This value of this limit is 1. If I graphed it at 16, the height of both sides is 1. You like direct substitution? If you can do it, try it first. If it doesn't work, our first, like this is like your second option. If direct substitution doesn't work, so can't sub yet because you can't divide by 0, we factor top and bottom, and it's still a limit. You're just writing the limit. One of the big issues that you guys, depending on who you have for calculus, that you need to have those limits. If you're taking the AP exam and you drop the limits in a free response question, you could lose the whole points or whole 2 points of credit, because sometimes that's important in the problem. But I'm going to factor this. Don't forget to keep writing the limit. So are you okay with that x coming out? They both have an x I can factor out. The benefit of factoring is identifying something that cancels. And I hope you see the x's will cancel. So what we'll do is, in each one of these, you want to factor first. And then you're going to cancel whatever you can, so you cancel something. And the new limit's going to look like this. The limit as x goes to 0. Oh, not in, I just wrote infinity. As x goes to 0. If those cancel, it's just 4x minus 5. And that point, right after canceling, you should be able to direct substitute again. It's just that we couldn't do it at first because it would cause division by 0. Now it's okay. And we can do 4 times 0 minus 5. So even the limits where you can't direct substitute at first, there's probably an algebraic way to get that thing to cancel, and then you can direct substitute and get -5. So that's the value of that limit. If I graph this and I go to x equals 0, the height is -5. Hey, we should do that. So, oh, look at that. That's fun. So here it is. Graphs up. Shall we? Y equals 4x squared minus 5x, bingo, over x. As x approaches 0, let's look at the height. You guys know how to do let's get our hands out from the left towards x equals 0, from the right as x approaches 0. It's a general limit. They both go to a height of -5, like we figured out. And if you walk to -5, why don't we just plug in 0? But if you remember, you can't. Look at 0, there's a hole. So we know the height is -5. That's, if I gave you a graph, just put -5 because you can see it. But if you don't have a graph, this is the algebra that we've learned to do to get the same result. And it's much more robust because sometimes the graph is too hard to interpret. Graphs can be kind of, remember the line box of batteries approach we had to graphing? It definitely applies with limits. Next one. That I cannot direct substitute. So no sub yet. But if you factor it, you totally can cancel that x plus 7. And you'll start getting used to the fact that whatever's in the denominator, I want to cancel an x plus 7. It kind of points you in the direction of I could probably factor out an x plus 7 on top. Until problems get more difficult, you're generally going to see that type of thing pop up. What would go with it? Do you remember the factors of 2 and 1 and 7 and negative 1? If I do 14, take away 1, that works. So it's 2 and 7 got paired, so it's 2x minus 1 times x plus 7. And then we cancel. But that's the factoring part. You always factor, then you cancel, and then you do the limit, and you direct substitute after canceling, and you should be okay. Boom. And negative 7 goes in, directly sub, and you get 2 times negative 7, minus 1, negative 15. Bingo. So the value of that limit, the height that both sides, if you approach negative 7 from the right and left, the height would be negative 15 if you graphed it. That's the story on those. Nice, right? It's going to be that easy for the